Hello, this time AC Ohm's Law Level 1, first of the real questions. Right, magnitude of the voltage source. If we only want magnitude, then we don't have to worry about the phase at all. We can just deal with the fact that V equals I times Z, which in this case it's a resistor, so the impedance of the resistor is just R equal to the resistor. This is just good old Ohm's law as we know and love it. If we want the magnitude of the voltage, we just have to take the magnitude of the current multiplied by the resistance, so that would just be 60.6 microamps times the value of the resistance, which is 33. Answer 60.6 micro times 33, and we're done. Next. Phase of current in degrees should the ammeter read. This is very, very easy because that's a resistor. And for a resistor, the phase of the current is always the same as the phase of the voltage across it. So the answer is just 180. Next. Okay, what phasor would represent the current source? And again, we don't have to think about the phase at all. We know the phase of the voltage, and the phase of the current is equal to the phase of the voltage for a resistor. So we know the phase is 90 degrees. All we need to know is the amplitude. And the amplitude of the current is going to be just the usual 6 micro divided by 1K2, and that's going to be at 90 degrees, same phase as the voltage. Notice I've put the amplitude in brackets, otherwise it might think the answer is 6 micro divided by the complex number 1K2 at 90 degrees, and 6 micro divided by 1K2 at 90 degrees is of course at minus 90 degrees, the answer, which is not what I want. So put that there, got it. Plus 90 degrees. Great. Next. A capacitor. Right. What value does the capacitor have? We did a similar one to this back at level 0. The idea here is that we're using the fact that V equals IZ, and that Z for a capacitor is 1 over omega times J times C. So if we want to know what the value of the capacitor is, that would be C equals I over V times 1 over J omega. We know that the capacitance is real. There's no such thing as an imaginary capacitor or a complex capacitor. It must have a capacitance which is absolutely real. So we don't really have to worry about the phase of this at all. We could just ignore the J, take the magnitude of I and the magnitude of V and sort it out that way. So my capacitor must be the current, which is 2 microamps, divided by the voltage, which is 15.9 volts in terms of amplitude. And again, not worrying about the phase because I know that my answer must be real, divided by the frequency in radians per second, which is 2 times pi times the frequency in hertz, which here is 200 kilohertz, it tells you there. So that's it. 100 femtofarads, pretty small one. Next. That'll do. Here. We've got a capacitor here, and we know the phase of the voltage, and we're asked what the current is. Well, you've probably come across the acronym CIVIL, C-I-V-I-L, which tells you that for a capacitor, the current leads the voltage. The current comes before the voltage, and it comes 90 degrees before the voltage. So if the voltage is 90 degrees, the current must be 90 degrees before 90 degrees, or a total of 180 degrees. We know what the capacitance is in farads, but to work out the current using V equals IZ, or here V equals I over j omega c, we're going to need to take I equals j omega c times V. We know the phase of the current, already worked that out, 180, but the magnitude of the current is going to be given by omega c times V, which is 2 times pi times 20 kilohertz here, that's the frequency we're going at, multiplied by the capacitance, 1.5 nanofarads, multiplied by the magnitude of the voltage, 90 millivolts. That's the magnitude. Put all that in brackets. The phase is, as we've worked out, 180. Great, done. What phasor would represent the current source here? Well, this time I'll forget that I knew about the acronym CIVIL, and I'll work it out as a pure complex calculation. The current source, I, is going to be given by V divided by the impedance, Z. And in general, all of these can be complex quantities. V is 1.59 at minus 90 degrees, and Z is going to be here, well, it's a capacitor, 1 over j omega c. Work all that out. Well, that would be 1.59 at minus 90 degrees divided by 1 over j omega c, which is j. I can just use j to represent square root of minus 1. Omega is 2 pi times the operating frequency, 500 kilohertz in this case, times c, 1 picofarad. Boom. And just let the inbuilt calculator sort all that out, and it will give you a 5 microamp and phase 0. If the phase is 0, it doesn't bother to write at 0, it'll just say 5 microamps. It's a real 5 microamps. Okay, that's probably enough to get you going with level 1 of AC Ohm's Law.